Okay, so we're going to start here with the unit circle. Okay, so let's talk about what a unit circle is. Unit circle is a circle that is centered at the origin and has a radius of 1. So what that means is from the center to any point I draw has a distance of 1. So that means that this point is 1, 0. This will be the point 0, 1. This will be the point -1, 0. This will be the point 0, -1. So what does that mean, unit circle? It means if I draw from here to any point, the distance from the center to the edge is 1. It has a radius of 1. That's my unit circle. So we're going to start let's first start by talking about our 6 trig functions. And then we're going to take those 6 trig functions and we're going to apply them to this unit circle. Okay, so does anybody remember the 6 trig functions? Sine of theta, cosine of theta, tangent of theta, secant, cosecant, and cotangent. So I'm going to go with cosecant, secant, cotangent. So, like, in my head, this is just the way I think about them. I think of these as the big 3. Sine, cosine, tangent, these are the supporting cast. Right? These are they're kind of like their co-stars. Cosecant, secant, cotangent. So the big 3, all these are ratios from a given angle of a right triangle. Right? We have to have right triangles. So if I'm looking for sine of an angle theta, what is the ratio for sine? Does that sound familiar to everybody? Everybody seen that, heard that? Cosine? Adjacent over hypotenuse. And tangent? Opposite over adjacent. And so you're going to have those 3 things memorized. You're going to have to know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. It's non-negotiable. Everybody's got some way they have to remember it. I used to say SOHCAHTOA, right, and that helped me know the first letter of each one. SOHCAHTOA. Our old geometry teacher, Miss Kurt, she taught us a saying that was, "Saddle our horses, canter away happily to other abodes," which I imagine would be great like in the 1800s or something, but I don't think it has a lot of relevance. Then I had a chemistry teacher that taught me one that I remembered. Some old hippie caught another hippie tripping on acid. However you remember it, I don't care. Okay, you've got to remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent's opposite over adjacent. Okay. Now, we'll talk about these 3 supporting cast guys later. Okay? But for now, let's focus in on the big 3, sine, cosine, tangent. So the theta is there for a reason, and people get this mixed up all the time, so I'm going to go ahead and teach it now. say that I had two angles here. This is angle alpha, and that's angle beta. Let's say across from alpha is A, across from beta is B, and then across from the hypotenuse, or across from the 90-degree angle, would be my hypotenuse, which is C. So if I ask you to find sine of alpha, what does that mean, sine of alpha? This tells me what angle to go to initiate my ratio. So I would go to angle alpha, which is here. And from alpha, I'm going to write the ratio of the opposite to the hypotenuse, right? Which in this case would be A over C. In this exact same triangle, if I ask you for sine of beta, is it the same? No, because for sine of beta, I'm going to angle beta here. And from this angle, I'm identifying the opposite as B and the hypotenuse as C. So the only thing that stays the same is the hypotenuse. It'll never change in the right triangle. But which side is opposite and which side is adjacent will depend on what angle I am looking from. Okay? Is this like mind-blowing to anybody, or has everybody seen this, somewhat familiar? You think, I'm good with that, I can keep going. Okay, so when we move into the unit circle, in this unit circle, remember, every line I draw from the center to the edge has a radius of 1, because it's a unit circle. So let's say I picked any random point. So I picked this point here. This is point X. This is point Y. I don't care what they are. Just some X and just some Y. I can build a right triangle with this as my hypotenuse. Think about if I went to the right some distance and I went up some distance. Now, how much did I go right? What is this value here? It is the same as the X value. Whatever point I'm on is how far I went over. And then how far did I go up? That's my Y value. So what have I created? I've created a right triangle. Now, this is what the unit circle is going to look like. We're going to be drawing right triangles all around in all the different quadrants. Okay, that's why I told you it's important to know where does it rotate me to. What quadrant does it put me in? Because that's what we're fixing to be working with quite often. Okay, so what was I going to say? I know what I was going to say. My angle. So we talked about how we can have different angles, alpha and beta. In the unit circle, our angle of rotation is always the angle touching the origin. So no matter where I draw my triangle, whichever angle is touching the origin, that is my central angle. That's the angle I'm starting with. So I'm just going to call this angle down here angle theta. Let me zoom in so I can draw theta. Okay, that's angle theta. It's the central angle. It's always what's right there touching the origin. So let's think about my trig function on the unit circle here. And remember, this is not a specific point. This is any generic point. So what we're fixing to discover will work for any case. Okay, so if I was to find sine of theta for this specific triangle, so from theta, what is opposite? The y value. What's the hypotenuse? 1. So sine of theta is the y value over 1. Or we could just write that as y. Okay, that's where that comes from. So sine of theta is always equal to the y value. So wherever I'm at on the unit circle, the y value is the same as sine of theta. Now let's look at cosine of theta. So from this same angle, what would be the adjacent side? X over the hypotenuse. 1, which would just be X. And then lastly, we have tangent of theta. So tangent of theta would be the y value over the x value, right? The opposite over the hypotenuse. So these three things are going to be very important to us. You need to make sure that you know those. That sine of theta is the y value, cosine of theta is the x value, and tangent of theta would be y over x. Kind of disjointed, but in that unit circle, I could draw all kinds of triangles. Right? I could draw a triangle in the first quadrant, second, third, fourth. I can make the triangle really like thin. That's what I would call it. Like if I drew a triangle here, right, that's a right triangle that I can make thin. I can make a right triangle that is up here. Be very tall and thin. I guess this will be wide. I guess I'm saying it the wrong way. But I can fit all these triangles. They all look different. But they're all got a hypotenuse of 1. They've got an opposite side and an adjacent side, no matter where I draw the triangle. There are going to be 2 special right triangles that we use all the time that you're going to have memorized. You probably have seen these, I think, before, but maybe you haven't seen them explained exactly the way I'm going to use them. Again, I call these my SRTs, my special right triangles. They are a 30, 60, 90, and a 45, 45, 90. Okay, what these values refer to are their angle measures in degrees. Thanks. So for my 30, 60, 90, I'm going to draw a right triangle that has a 30-degree angle, a 60-degree angle, and a right angle, 90 degrees. You seen these before? No? It's fine. You have? Do you know what value goes across from the 30? No, the side values. So maybe, like I said, the last class didn't think they'd ever seen it. So for a 30, 60, 90, across from the 30-degree angle is always a side with a value of 1. Across from the 60-degree angle is always a side with a value of radical 3. And across from the 90-degree angle is a side with a value of 2. So 30, 60, 90 has 1 radical 3 and 2 as its side lengths. And that's the only 30, 60, 90 triangle you'll ever see me draw. Okay? The 45, 45, 90 triangle, there are 2 of them. You can learn just one of them and then learn how to convert. You can learn both of them and then pick which one is most beneficial. When I first learned it, I only learned one of them, but I didn't care to work with fractions and convert them. But now I've done it so much I know them both. So here if I've got a 45, 45, 90, those are 4s, sorry. So 45, 45, 90 special right triangle. The one that I first memorized, across from the 45s, I have radical 2s. And then across from the 90, I have a value of 2. And then the other 45, 45, 90, across from the 45s, you have a 1. And across from the hypotenuse is a radical 2. Okay, either one of those is acceptable. And I'll go back and forth. Like, I don't even mean to anymore. I'll write whichever one's most convenient for the problem. But that's where those come from. So, have you seen those before? I got a mixed bag. That's fine. these are more things you're going to have memorized. So far, what do we have to have memorized? We have to know sine, cosine, and tangent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Then with a unit circle, we learned that sine is equal to the y value. Cosine is equal to the x value. Tangent is equal to y over x. And now we've learned these two special right triangles, or these three special right triangles. 30, 60, 90, and 45, 45, 90. Okay? Let's do one more rule here. Let's do that. So let's think about, what if I was rotating on the unit circle? So again, I can rotate any amount of degrees or radians we want to. It's just a complete cycle. It'll put me in a specific quadrant. So let's just say, for instance, that I've rotated and I'm in the first quadrant. All right, so let's think about it. What would the x value be in the first quadrant? Now, this part here, what I'm fixing to do, you don't have to write all this down. If you'll follow this part, I'm going to tell you the trick in a second. But let's think through this together. So, if I think about this as being my x value, my y value, and 1, right, for my unit circle. I can't say a lot about this x value, but what can I say about it? Because of the quadrant I'm in, it's positive. The x value is positive because I went to the right. I can't say a lot about the y value, but what can I say? That it's positive. And the hypotenuse is a radius. The radius is always positive. It's never going to be negative, no matter where you draw it, because it's a distance on the unit circle. Okay, so if you think about all of your trig functions, or your big three trig functions, sine, cosine, and tangent. If I were to take sine of this central angle, it would be positive y. If I was to take cosine of this central angle, it would be positive x. If I was to take tangent of this central angle, it would be y over x, and they're both positive. Right? So if we think about it, in the first quadrant, we had sine was positive, cosine was positive, tangent was positive. Now let's go to a different quadrant and think about what would happen there. So what if I went in the second quadrant? Now, what's my x value? Negative. What's my y value? And what is my hypotenuse? Positive. It's always positive. Always positive 1. So in the second quadrant, from my central angle, theta, if I did sine of this angle, it would be y over 1, which would be positive. Both those numbers are positive, so I would get sine to be positive. If I did cosine of this angle, I would get adjacent, which is a negative number, over hypotenuse, which would be negative. So cosine would be negative here. And tangent of this angle would be the opposite, positive over the adjacent, negative. Positive over negative is negative. So in the second quadrant, the only one of your big three trig functions that's positive is sine. Everybody follow my logic? Look in the third quadrant. My x value is still negative. My y value is negative. And the hypotenuse is still 1. So if I went from this central angle here, sine is the opposite, negative, over hypotenuse. So in the third quadrant, sine is negative. Cosine would be the adjacent over the hypotenuse, which would be negative. Tangent would be the opposite, negative, over adjacent, negative. It's a negative over a negative, so tangent would be positive. And then in the fourth quadrant, again, I've got a positive x, I've got a negative y, because I went down, and the hypotenuse is still 1. So from this central angle, sine would be the opposite, negative, over hypotenuse. So sine would be negative. Cosine would be the adjacent, positive, over the hypotenuse. positive. And tangent would be the opposite, negative, over adjacent, positive, which would be negative. So what's happening here is in the first quadrant, everything's positive. But in the second, third, and fourth, only one of them is positive. And so the way that we remember this, you'll see this, I'll write this down about every problem we work. You got a little saying that we learned. All students take calculus. All right, that's the way I learned it. There's all kinds of different ones you can probably find on the internet. But I remember this. All students take calculus. What does that tell me? All. That means all of them are positive. Students. Only sine is positive. Take. Only tangent is positive. Calculus. Only cosine is positive. Okay, that's my little saying. That's the way I remember it.